So the last few classes we've been talking about rational functions, and so we graphed them using two new basic functions. Then we learned about process for graphing when they're a little more complicated. Then last time we solved equations and inequalities involving them. So now we're gonna, for the last two sections, we're gonna change concepts a little bit. So we did some brief focus on rational functions, and we're going to turn our attention back to a function or a type of function that's a little more familiar, which are the radical functions, things that are defined by roots. So the first couple problems of this section, again, is going to draw on a little bit of our intermediate algebra knowledge. So I'm going to ask you just a quick question about the first problem. So if I have 16 to the 3/4 power, okay, so this is something we talked about in intermediate algebra. But in case you don't remember that, I didn't want to assume, so we'll do a couple of review problems. Does anyone remember how to translate an exponent that's a fraction into a radical? Do you remember the process for transferring something like this, 16 to the 3/4 power, into something that has a radical? How would you write it? Okay, so the essence of what you're saying is true. So the 4, so here's the thing to remember, everybody, in case you don't. When you have a fraction in your exponent, it's really telling you a root. It's just another way to communicate that. Whatever the denominator is becomes the index of the radical. So this is telling me that I have a 4th root of 16 to the 3rd power. Okay, those mean exactly the same thing. Now, I'm now going to evaluate the rest of this. Okay, that sounds like a fun thing to do. I'm just going to do it without my calculator to show that that's possible. So what I'm going to do is, since 16 does have a 4th root, I'm going to do that first. When you don't have any adding or subtracting or anything else to do, when you just have something raised to a power and a root, you can do these two things in whatever order you want. And since raising 16 to the 3rd power is a large number, what I'm going to do is I'm going to do the 4th root of 16, and then I'll raise that to the 3rd power. So all three of these things that I have written consecutively all mean exactly the same thing. 16 to the 3/4 power is the same thing as the 4th root of 16 to the 3rd, which is the same thing as the 4th root of 16, that raised to the 3rd. Okay, so any one of those means the same. And now I'm going to evaluate this. The 4th root of 16, the number that times itself 4 times gives me 16 is going to be 2. So now I have 2 to the 3rd power, and 2 to the 3rd power, 2 times 2 times 2, that just becomes 8. So the one that's right below it, the -64 in parentheses raised to the 4/3, I just want you to do the first step. I want you to rewrite that as a radical, and then we'll talk about simplifying it. Okay, so hopefully what you wrote down, all I wanted you to do was write this as a radical. So I'm going to write this as the 3rd root of -64. Because we're going to simplify it in a minute, I'm going to use the second of these things. But if you wrote the in parentheses, let me write them all just in case. So if you wrote it like this, the 3rd root of -64 to the 4th, that's fine. I'm going to write it as the 3rd root of -64, and then I'm going to raise that to the 4th, because that's going to be a little bit easier to evaluate. But my only instruction to you was to rewrite this thing with a fractional exponent as a radical. So either of these two things right here are perfect. Anybody got a question, comment, or concern? If you do, let me know. I know it's probably been a while. It's been like 4 or 5 months even if you took intermediate algebra last semester. All right, so now the third root of negative 64, what number times itself 3 times going to give me negative 64? Your calculator could easily tell you that's going to be negative 4. And then negative 4 to the fourth, that is going to be, I think, if I'm doing my mental arithmetic, you should definitely check this. I think it's 256. Negative 4 times negative 4 times negative 4 times negative 4. So my calculator disappeared, so I'm forced to use my brain this morning, which is scary. Anybody got a question? Because I'm going to put a few of these on the test. Nice review problems, hopefully something you already know how to do. Hopefully it's just free points. That's why I'm going to put them on there. So if you're not understanding what's going on, now is the time to talk about it. All right, the last one, what we're going to do here is we're just going to do the reverse process. We're going to take this thing that's written as a radical, and we're going to practice writing it with an exponent. And so I'm going to take my z, and just like with the first problem, I circled the 4. Whatever is the denominator is the index of the radical, and that's vice versa. Whatever is the index of the radical becomes the denominator of the fraction. That goes back and forth. So my index of my radical is my 4. So I'm going to have z to the negative 5 over 4. The 4 is going to be in the denominator because it was the index of the radical. Now, I gave this problem because we have one more thing to do. I know it's been a long time since you've dealt with exponents, so I wanted to review as many things as I could. We don't tend to leave negative exponents negative. We're going to simplify that. Does anyone remember the process for simplifying a negative exponent? Okay, well, a negative exponent tells you location. Okay, it's telling you a position. And so what this is saying is your base is in the wrong place. So instead of the z being in the numerator with a negative 5/4, I'm going to write 1 over z to the 5/4. So negative exponents mean put your base in a different place. All right, well, that's my real quick, neat and pretty review of fractional exponents. There'll be more problems in the homework. In the meantime, I've got 3 problems next door. We're just going to do them one at a time because I want to give you any opportunity to ask whatever questions are necessary. So go ahead and simplify negative 125 to the 2/3. Please first write it as a radical and then simplify the number. All right, first thing to do, rewrite this as a radical. So I'm going to have the 3rd root of the negative 125, and I'm going to raise that to the 2nd power. Okay, so let me give you another 20 seconds just in case you're waiting for me to do that. So check your answer. You've got the 3rd root because that was the denominator of the fraction. And now go ahead and write down what the number value of that is. So the third root of negative 125, the number that times itself gives you negative 125. When you multiply it 3 times is negative 5. Negative 5 times negative 5 times negative 5 is negative 125. And then I'm going to square that. And negative 5 times negative 5 is positive 25. So that is the, whoops, I'm off the screen. That is the value, that is the result. Now, what I want you to do in this next one, again, I have an intentional reason for putting the next one on there. Notice that there's no parentheses around the negative and the 81. So that means that the 1/2 power is applying to something specific. So make your best attempt at negative 81 to the 1/2 power. Okay, so there's no parentheses around this negative and the 81. So the exponent is only applying to the 81. Okay, if there were parentheses, the negative would be part of the thing under the radical. So here's what we've gotten. We've gotten a negative that's outside because it's not being raised to that exponent. Since the denominator is a 2, this is a square root. You are welcome to write the 2 right there. Some places around the world, they do put the 2 in the index. In the United States, we tend not to because it's the most commonly used radical. So we're lazy, so we don't write the 2. Whatever you want to do there is fine. And then we're going to put the 81 under there. So the negative should not be under the radical on this problem. It would be different if I had written negative 81 like this with parentheses. In that case, the 1/2 is applying to everything. And so what you would say is that's the square root of negative 81, and then we'd write that as 9i. We'd have a completely different answer. This one, the negative is outside, so the result is negative 9. Everybody tracking on the difference the parentheses make in those two problems. Again, it's a little introductory algebra, but I know sometimes those details, they are easy to look over in the midst of all this. All right, last problem. Rewrite that thing that is a radical with a fractional exponent, please. So hopefully what you wrote, or hopefully what you noticed, is the index of the radical becomes the denominator of your fraction. So this is going to be a y. Well, first thing, I guess what I need to do is do something about this squared in the negative 5, but we'll take care of that in a minute. So what I've got is y, and I'm going to put this 2 over the 3, y to the 2/3 raised to the negative 5. Now, when I multiply things together, when I multiply my fractions, I just multiply my numerator. So I've got 2 times negative 5. So that's y to the negative 10 over 3. And then again, I've got that negative. I put that there intentionally just so that you'd have to write this down. But any negative exponent, we're going to resolve that by moving the base. So this is going to be 1 over y to the 10/3 power. And that's my result. All right, so fractional exponents, we're going to use those a little bit, especially when we come back next time and we solve equations that have these roots and they have these fractional exponents. What I'd like you to do now, just because it's been such a long time, I should have put some grids on. We're going to talk about the domain of some radical functions. Down below where we have this graph paper, just real quick, from memory if you can, or make your table, graph the plain old square root of x function. The plain old square root of x function. And then once you've done that, identify what the domain of the square root of x function is. It's been a long time since we've talked about it. It's one of our original 6 basic functions, the square root function. All right, so here's the basic square root function. I know it's been a long time, but we're going to get re-familiar with this. So the square root function, the square root of 0 is 0. That's where my graph is going to start. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. And so the square root is just half a parabola leaning on its side like this. And then what is the domain of that graph right there? All right, 0 to positive infinity. Sure, those are the x values. And what am I going to put at the 0? Do I put a parenthesis? Do I put a bracket there? A bracket. The 0 is included. So there's my domain from 0 to infinity. Okay, just refreshing our memory on our good friend, the square root function, because we're going to graph that again in just a minute. In fact, we're going to use that basic function to graph that function that's right above it in just a few minutes. So it gives you something to look forward to right there. All right, the reason I had us do that is for the following reason. Up above, I've asked, what is the domain of this, 9x plus 18? Well, what we just saw is for the basic square root function, the square root of x, the domain is from 0 to infinity. Okay, so for the square root of x, the domain is 0 to infinity. What that means is, as far as my graphing, as far as my functions, whatever is under the radical has to be bigger than or equal to 0. So when I ask you to find the domain of a square root, as an aside, this also applies to any even index function, but we're just going to keep our discussion to square roots and cube roots here because we're familiar with them. What you need to do is take this thing that's under the radical, the 9x plus 18. So I'm going to rewrite that, 9x plus 18. And we're going to say that has to be bigger than or equal to 0. As far as functions, as far as graphing, I can't take the square root of a negative number. So I'm not worried about complex numbers here or anything like that. So now it's just a matter of solving this. I'm going to subtract the 18 from both sides. And I get that 9x is greater than or equal to negative 18. Then I'm going to divide both sides by 9. And x has to be greater than or equal to negative 2, which I'll now write as an interval. So negative 2 to infinity. If you have a question about that, please ask. If not, then what I would like you to do is the one that is right next door. Please find the domain of the square root of 3 minus 5x. All right, so once again, all we do is we take this thing that's under the radical, the 3 minus 5x, and I'm going to say, okay, 3 minus 5x, that has to be greater than or equal to 0. So I'm going to subtract 3 from both sides and get negative 5x is greater than or equal to negative 3. When I divide both sides by negative 5, what do I have to remember to do with that sign? Got to flip it. Whenever you multiply or divide by a negative, you flip that sign. And negative 3 divided by negative 5, a negative divided by a negative is positive 3 over 5. So this is, the domain is going to be the x's are less than or equal to 3 over 5. So that means now we're going negative infinity. We're stopping at the 3 over 5. And that is my interval. Oops, sorry, I'm off the screen again. Can't control myself. There we go. Any questions about if I ask you, because I will, I guarantee you, when we have the test in a week from now, there's going to be a question that says, find the domain of this square root function. Okay, and I don't want you to miss out on those points. Any question at all? All right, then what I would like you to do is flip to the second page, and just like we did for the square root function, I want you for the cube root function, this exercise right here, the cube root of 64x minus 128, I want you to real quick graph the basic cube root function, okay, our basic function from way, way back. All right, so the cube root, if I'm graphing the basic function, the cube root of x, so right there, then I'm just going to plug in some values that I can take the cube root of pretty easily. So the cube root of 8 is 2. The cube root of 1 is 1. The cube root of 0 is 0. The cube root of negative 1 is negative 1. The cube root of negative 8 is negative 2. So we get this odd function right here. And it just looks like an airplane propeller. And there we go. There's my basic graph. And the reason I've asked you to do this is I want to draw on some prior knowledge. What is the domain of the cube root function? Write down real quick, 20 seconds. Write down on your paper, what is the domain of that graph that we just drew? All right, how far left does that graph go? Negative infinity, fantastic. How far right does that go? Yes, great. So it's all real numbers, negative infinity to infinity. So here's the difference, and this is what I'm trying to point out. The square root graph, when the index is even, the domain is 0 to infinity. And so when we were asked to find the domain of these things that are related to square root graphs, we set whatever was under the radical bigger than or equal to 0. Okay, that's where that came from. Now, in my next example right here, underneath the pink one, so let me grab this, I've got now a cube root right there. Well, we just saw what's the domain of the cube root? It is negative infinity to infinity. So when you see an odd index, and we're going to focus mainly on cube roots in here because that's what we're familiar with. When you see that odd index, you don't have to do any calculating at all. Your domain here is just going to be negative infinity to positive infinity because of the change in the index. So on the test, again, don't fall for this. Don't confuse these two things. The index is important for this question of domain. So I'm going to give you 6.5 seconds right across the street right here, the cube root of 2x plus 9. If you would, please write down what you think the domain of that is. key bit of information. Oh, actually, it's fifth root. Not wearing my glasses, I can barely see. So, but it's the same thing. We've got a fifth root right there. The key bit of information is that index is odd. Because that is odd, I don't have to do anything but say that the domain is going to be negative infinity to positive infinity. Done. All right, so we're done with the bulk of this section. We've just got these 5 graphs. We'll probably have some time left over. We'll do a little reviewing. Sure, you probably have some questions about solving equations and things like that. We can go through, find something in my math lab. That'll be fun for us to do. But the last thing to do, again, we just kind of resurrected this idea of graphing our square root and our cube root. So the question then becomes, okay, I've got something like this, the square root of 4x plus 12. Now, I know right away, because you haven't seen this before, right away you're thinking, oh, plus 12, I'm going to move the whole graph left 12 units. That's exactly what you're not going to do. Before you can make any conclusions about this, you have to do a little simplifying. And so the way we're going to simplify is we are going to, whatever number is in front of the x, we are going to factor that number out. Okay, so we are going to factor out the 4 out of these terms underneath the radical. So when I do that, I have the square root of 4 and some parentheses. When I factor the 4 out of the 4x, I'm left with x. When I factor the 4 out of the 12, I'm left with plus 3. I'm still not ready to make any conclusions yet because I've got one more thing I can do. The product rule of radicals says when I have a product under there, I can consider each of these two things separately. So what's the square root of 4? 2. And then I have the square root of x plus 3, which I can't do. Now I'm ready to make some conclusions about what this graph is going to do. Again, just drawing on your memory. I know it's review. I know it's been a little while since we've done this. What two things are happening to this graph right here? Okay, the minus 3 underneath the radical is going to move the graph left 3 units in the negative x direction. So we're going to go left 3. Fantastic. And then what's the other thing happening to this graph? Multiplying the y's by 2. Sure. All right, well, I'm going to do this one along with you. Again, just reminding you how this thing goes. When we have multiplying as part of our transformation, I recommend you always do that first as a separate step because it gets confounding when you try to do multiplying and translating at the same time. So I'm just going to go through with my black pen. I'm going to write down the dots for when I multiply the y values by 2. So this first y value is 0. It's going to stay 0. The next y value is 1. 1 times 2 is 2. So I'm going to make a dot at 2. The next y value is 2. 2 times 2 is 4. So I'm going to put a dot at 4. And then the last y value is 3. 3 times 2 is 6. I'm going to make a cute little dot here right at 6. And I'll just make a little dotted graph right here. And I'm going to label it. This is 2 times the square root of x. Just so that when you're looking at your notes later, you see exactly what it is that I've graphed. And now we're just going to take that whole thing and move it left 3 units. Okay, so left 3 units. So this is going to go 1, 2, 3. Make a cute little red dot right there. 1, 2, 3. Cute little red dot. 1, 2, 3. Another cute little red dot. And then one more. 1, 2, 3. Cute little red dot. And now I'm ready. This is my final graph, the red one. And there it is. If I'd asked you what the domain is, you would have set the 4x plus 12 greater than or equal to 0, and you would have got the exact same thing we just got on the graph, that the domain starts at -3 and it goes to infinity. So all things should relate to each other and be equivalent. If you got a question, I would relish a question and get a chance to interact about this. If not, I would like you to do the same sort of process for the example that's right next door. Go ahead and graph the square root of 9x minus 18. All right, so here goes. I'm just going to do the exact same thing. Doesn't matter what's going on here. The first thing you have to do if we're going to accurately assess this is factor out whatever that value is in front of the x. And if I've been a nice instructor, that'll be something you can take the square root of. And my plan is to be a nice instructor. Who knows, though? All right, so I'm going to factor out that 9. When I factor out the 9 from the 9x, I'm left with x. When I factor out the 9 from the negative 18, I have minus 2. Now I'm going to take the square root of the 9. This is the product rule of radicals, which says I could take the square root of each of these parts individually. So I have 3 square root of x minus 2. Does anyone have a question or a concern about where I got that from? Okay, then what are the two things happening to my square root of x graph? Okay, y's by 3. Sure, we're going to multiply the y's by 3. That's one thing. And what else? We're going to go right to. Excellent. So I'm going to just do the y's multiplied by 3 first. So this one's 0, stays 0. This is 1. 1 times 3 is 3. Make a dot. This is 2. 2 times 3 is 6. Make a dot. This one's 3. 3 times 3 is 9. I'm going to make a dot. So we get this nice, really cute, stretched out graph. Love it. There it is. This is 3 square root of x. And now I'm going to, just like you told me, hopefully you've already done this. We're going to move this whole thing right 2 units. So right 2, and then right 2, and then right 2, and then I'm going to guesstimate right 2's right about there. And whee! There's my nice green graph. Before we flip the page, just got a couple more. Any questions? Anything that's unclear? All right. I put one more square root on just for fun. I put a negative out in front of it just to keep things nice and spicy. So go ahead. I'm going to give you a couple minute or two to go ahead and do this. The only difference in this problem with the previous ones is I've got a negative out in front of this one. It doesn't change anything procedurally. Underneath the radical, I factored out that 16. When I factor out the 16 from the 16x, I'm left with x. When I factor out the 16 out of the negative 16, I'm left with -1. According to the product rule of radicals, I can now take the square root of each of these things individually. I can take the square root of 16. Square root of 16 is 4. And then I have that negative that was out in front, so don't forget that. Underneath the radical, that doesn't change. I can't take the square root or simplify that at all, so it stays square root of x minus 1. And then I'm pretty sure that you would have told me this means I'm going to multiply my y's by -4, and I'm going to move everything right 1. Anyone disagree with me or not see why? If you're not clear, that's a great time for a question. That's what we're all about here. All right, well, now I'm going to go through. I'm going to first multiply all my y's by -4, so 0 stays 0. This is 1. 1 times -4 is -4. This is 2. 2 times -4 is -8, so that's right here. This is 3. 3 times -4 is -12. So here's 10, 11, 12. We're gonna pretend that we know where that is. And so here's my really stretched out, elongated graph. So this is -4 square root of x right there. And then we're just going to take that whole beautiful graph and we're going to move the whole thing right 1 unit. So right 1, and then right 1, and then right 1, and then right 1 to right about there. And let me do a nicer job of graphing this. Boom. There it is. Okay, so that's square root. We've done 3 of them. I'm hoping that seems pretty plain to you. And when I put 1 of those or 2 of those on the test, because I'm going to, that you're going to eagerly want to do those and graph those and tell me what the domain of those is, because those are the questions I'm going to ask. Test is going to be no different. I don't know if you've noticed this about this class. We're in the 4th unit. I just put on the test things that we've done in class, literally. Okay, so do your homework, take those quizzes, get that quiz grade good, review your sheets we've done in class, then there's absolutely no surprises. I am not super creative. Okay, all right, so next thing, we're going to end with a couple cube root graphs. Same process. So I would like you to do this one right here, cube root of 64x minus 128. Okay, so again, it's going to start off with you factoring out that value in front of the x and applying the product rule of radicals to that. All right, so I factored out the 64. It's always this number in front of the x. That never changes. So 64, and then in parentheses, x minus 2. Cube root of 64, 4 times 4 times 4 gives me 64. So that's my cube root. Notice this is not a square root. So if you have an 8 written in front of the radical, then pay attention to the index, please. And then I have x minus 2. So again, just like the other problems we've done, I'm multiplying the y's by 4. I'm moving the whole thing right 2. So my y is by 4. This y value over here is negative 2. So that becomes negative 8 when I multiply it by 4. This y value is negative 1. So it becomes negative 4. 0 stays 0. 1 times 4 is 4. And then 4 times 2 becomes 8. So here is the dotted version. I'm just going to do this nice and light because I don't want to make this too much of a mess. So there is my 4 times the cube root of x graph. And now I'm just going to move that whole thing right 2. So right 2, and then right 2, right 2, right 2, and then finally right 2. So here is my cube root graph. All right, your time for questions is running short. Okay, we've got one more example we're going to do, and then that's it for section 5.4. So if you would, right there, last one, it's another cube root graph. Have fun. Enjoy yourselves. All right, so this last problem, I had an 8 in front of the x, so I factored it out. So I have 8 times x plus 1 now. Remember, we can redistribute to verify that we've got that. 8 times x is 8x, 8 times 1 is 8, so we're good. Now the product rule of radicals says I can take the square root of that 8 all by itself, cube root of 8 all by itself. Cube root of 8 is 2. Then the cube root of x plus 1 stays under the radical. And so we can see, since that 2 is out in front, I'm multiplying the y's by 2. And since I have the plus 1 with the x, I'm moving the whole thing left 1 unit. So I'm going to multiply the y's by 2. And while I'm doing this, if you have any questions, bring them up. This is negative 2 times 2 is negative 4. This is negative 1 times 2 is negative 2. 0 stays 0. 1 times 2 is 2. And then 2 times 2 is 4. And so again, here's my dotted little graph. That is 2 times the cube root of x. And then I'm going to move the whole thing left 1. So this point goes left 1. This one also, as well as this one more time. And there it is. There's all of my left 1s. And there is my kink graph final answer. All right, I'm going to end this.